Hello everybody, David Shapiro here for another video about Raven. Today I'm talking about the SOLR application as well as the encyclopedia service. So I've already shown another video about the encyclopedia service, which is basically Wikipedia, but it was running on SQLite. SQLite has a lot of limitations, namely that it's just a relational database. And it's also not meant for large data sets. SOLR, however, is a search engine. So if you think about Google, Google is the most familiar search engine to most people. It has things like analytic and semantic understanding to help you with search functions. So what SOLR does is it gives you that same power, but it gives it to you locally. So first, I need to show you what SOLR is and what it does. So this is Docker desktop running my instance of SOLR. And actually, I meant to bring this up. Localhost SOLR admin. There we go. Okay, so here's SOLR, and SOLR is organized into cores. And what a SOLR core does is basically a core is like an index database. That's the simplest way to put it. I'm not going to do a deep dive into SOLR. If you're curious about how SOLR works, there's plenty of material out there to look on it. But I just wanted to show you that I've got 267,000 documents in this index, in this core, and it took let's see, that's about 400 gigabytes, I think, or megabytes. Let me show you. SOLR data. So within data, I've got the wiki core, and it is 343 megabytes. So SOLR is also very efficient. Yep. So there's that. Let's see. Go ahead and, oops. There we go. Okay, so within the plain text Wikipedia GitHub repository, I've now got, let me minimize that. There we go. I've now got a few files. So that's the point of today's video, is I wanted to show you how all this works, to bring it all together. So let's go to the plain text Wikipedia directory. Okay, so first I've got a batch file, and this can be rewritten for Mac or Linux. And basically what this does is, all it does is tell Docker to run SOLR. And what it does is it says, use this directory for your data. And then it says, use this NAT. Map port 8983 to port 8983. Use the SOLR pre-create script and call it wiki. So there you have it. It's pretty simple, and that causes this to run here. And you can rename this whatever you want. So there's that. And then going back to the directory, so that's how you start SOLR. It's pretty simple, pretty straightforward. And then let's see, Wiki Functions. So this is really the meat and potatoes of using Wikipedia as a data source. What I've done is I've created a Python file that's got all of it separated out into individual functions. So for instance, I've got this one that says remove simple links, and it's got the regex for that. Then it's got compound links, all other links, pictures, remove audio files, so on and so forth. The reason that I use regex or regex, I don't know, I just say regex. The reason I use regex is that it is way, way faster than wiki text parser and HTML2 text. So when you've got the full Wikipedia is something like 6.5 million articles. If you use regex, you can process about, 20 articles a second. If you use HTML to text and wiki text parser only, it can take 5 to 10 seconds per article. And so you do the math, it takes a couple hundred times longer to do it with using wiki text parser and HTML2 text. So I rely heavily on regex. Your mileage may vary. There's still a few things that I need to figure out. Primarily, the tables, wiki tables. I have not figured out a good way to parse that data into something that is just plain text. Let's see. So there's that. I also created a second file just for SOLR functions. It's pretty straightforward. All it does is if you give it a payload, if it's a single dictionary, then it will send it to one endpoint, and if it's a list, it'll send it to another. Another key point is the URL argument there, commit within. If you don't have that, then SOLR will just keep it in memory until you tell it to commit. So I say I give it 5 seconds to commit, so that way it can keep up. One thing that I found was that sometimes as using posts as fast as you can go, sometimes SOLR needs a second and it'll crash. So rather than have it just fully crash out, I gave it a while true loop, and I gave it 6 tries, so that if it failed after 6 tries, then it would bomb out. But invariably, it would usually go through after 1 or 2 tries. Sometimes I saw it take 3 tries for the SOLR engine to catch up. And the problem there was that I was sending in individual dictionaries at once. If you send a larger payload, but slower, it's entirely possible that it won't crash as often. This is going to be subject to improvement. Let's see. So those are the 2 functions, and then the start SOLR bat. I guess that's pretty much it. I just wanted to show this. Here's the final test that I made. You can see it's what, 4 lines from Wiki Functions import all. Here's the file name, which is just an export of the simple wiki, simplified English, and then I use this function, process file to SOLR. I guess I can show you that function. So right down here, process file to SOLR, you give it a file name, it goes through the article, opens that file, and then goes through line by line. I detailed in the previous video about parsing Wikipedia, and that is that the exports, the XML exports, are too large to hold entirely in memory, so you have to read them line by line. Fortunately, the exports are organized in such a way that it's really easy to separate out each individual article. Every Wikipedia article starts with this tag, page, and ends with this tag /page. And so you know if you see this, you're at a new article, and if you see this, you're at the end of the article. And otherwise, just accumulate the lines, and then once you get all the lines in an article, I use the analyze chunk. I pass that along, and then find the key information, such as the article ID, the text of the article, and the title. So there you have it. It's pretty straightforward. SOLR is working, and it's pretty efficient. It's certainly more efficient and more powerful than SQLite. And that will serve as the underpinning technology behind Raven's encyclopedic services. So I'm not going to stick with just Wikipedia, but also with Raven's recall services, which will give Raven a long-term memory. And I'm going to make another video about those and post that later. Thanks for watching.